All right, question number 2. This one just wants to know what is a vertical asymptote. So that's just an imaginary line that the graph doesn't cross. What causes that to happen is a value in the denominator that causes us to have to divide by 0. So according to the definitions, if we look at these, it says a vertical asymptote is a line y equals a. Well, y equals a is going to be a horizontal line, and a vertical asymptote is a vertical line. So we can just eliminate a and b from there and look at C and D. So a vertical asymptote is a line x equals a. Looks good so far. Where the limit f of x is equal to positive or negative infinity. Well, that's close, but it's not quite right. Okay, so just for example, if we look at the rational function 1 over x, okay, this graph has a vertical asymptote at 0. The graph does not cross the line x equals 0. However, the limit is not positive or negative infinity. As you go to 0 from the left, we go to positive infinity. As you go to 0 from the right, we go down to negative infinity. The only way that the limit would be positive infinity or negative infinity is if both sides went up or both sides went down. However, that doesn't happen, and we still have a vertical asymptote. So C doesn't quite satisfy the definition. However, we look at D. A vertical asymptote is a line x equals a, where either the limit of f of x as x goes to a is positive or negative infinity, the limit of f of x as x goes to a from the right is equal to positive or negative infinity, or the limit of f of x as x goes to a from the left is positive or negative infinity. So this would satisfy all conditions, because you can look at a left side limit and a right side limit, and they either go to positive or negative, or the overall function could go. So D would be the best answer for that definition. And then number 3, we want to consider the function f of x, which is equal to little f of x over little g of x. And it says g of a is equal to 0. It says, does f necessarily have a vertical asymptote at x equals a, and explain your reasoning. Okay, so we have some different ones to look at. So does that mean we have a vertical asymptote? I would say no, based on the GeoGebra problem, because if it equals 0, it could factor out and you have a hole. So instead of looking at the yes, I'm looking at the 2 no scenarios, and this one says no. For example, if you have x squared minus 4 and g of x is x minus 2, this is a difference of squares, and a equals 2, the function f does not have a vertical asymptote at x equals 2, even though g of 2 is 0. So yes, this works. This would be the case where you have something cancel out. So if you have x squared minus 4 over x minus 2, you can factor this out with difference of squares. This will give you x plus 2 and x minus 2. And then still you have an x minus 2 on the bottom. Now, this one says if you plug in a 2, you'll get a 0 on the bottom. But since these 2 terms cancel out, what will happen on this graph is instead of you having an asymptote, you would have 1, 2, up 1, right 1, up 1, right 1. You would have a hole in the graph when you get to 2 instead of an asymptote. So that's what would happen. So you can have a denominator value of 0 but not necessarily have an asymptote. So A would be the one that really explains why that happens.